We're talking about blue whales, the Earth's largest creatures whose songs once traveled across entire ocean basins. They have mysteriously stopped singing in unprecedented numbers.
Of the largest tooth predator on the planet, an animal bigger than a school bus with perhaps the most sophisticated form of communication that has ever existed.
Ever wondered what whales are really saying deep under the waves? Scientists just pulled off something straight out of science fiction. They had a 20-minute chat with a humpback whale using AI. But here's the twist. What they discovered about this ancient ocean language is not at all what you'd expect.
A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Did it say I'm tired of fish? I'm tired of plankton?
I have.
So this team, including a professor from UC Davis, is hoping for more interspecies dialogue following this groundbreaking exchange with a whale named Twain. Want to hear more? I do. Here's Kayla Muller with more.
From mystery to science. For a long time, whales were seen as strange giants of the ocean. Early sailors often spoke about deep sounds that carried through the water. They described them as ghostly calls that echoed across the sea. No one could explain them clearly, and many believed they were only strange noises of nature. In the 1970s, things began to change. This was the time of a growing environmental movement when people around the world started to care more about the future of animals and oceans. Scientists began recording whale sounds, and soon everyone could hear them in clear detail. The calls of humpback whales were rhythmic and patterned like music that carried meaning beyond simple noise. One of the most important moments came in 1970 when an album called Songs of the Humpback Whale was released. The recordings surprised and moved millions of listeners. They played a major role in the campaign to stop commercial whaling. People began to see whales as complex creatures with voices of their own rather than silent beasts of the sea. Yet understanding what whales were saying remained limited. The tools of the time were simple and could only capture and replay sounds without deep analysis. Scientists relied on guesswork, and many ideas stayed unproven. These early steps created interest and wonder, but the real decoding of whale communication had to wait for stronger tools, like artificial intelligence. Dr. David Gruber is a marine biologist and a National Geographic explorer who has spent many years studying ocean life. His research often focused on unusual creatures such as glowing corals and bioluminescent fish. Over time, he grew more curious about whales. To him, they seemed like the greatest mystery of the sea, and perhaps the best example of intelligence that humans had not yet understood. Gruber found inspiration in a surprising place. He followed SETI, the search for extraterrestrial intelligence, a project that listens for possible signals from outer space. The goal of SETI was to discover new forms of life beyond Earth. Gruber began to think in a different way. What if another kind of intelligence already lived with us here on Earth? Whales are ancient mammals that form close families and create rich cultures through sound. Communicating with them could be the closest experience to meeting another kind of mind. This thought led to the creation of Project CETI, the Cetacean Translation Initiative. Gruber brought together experts in biology, linguistics, robotics, and artificial intelligence. Their shared dream was simple to describe, but difficult to reach. They wanted to use the newest tools of science to decode whale sounds and open a path toward real understanding of another species. But understanding whale songs was just the first step. What came next would require bringing together the smartest minds from completely different worlds. Building the dream team. To bring his idea to life, Dr. David Gruber needed more than his own expertise. He needed people from many areas of science working together as one. Marine biologists could explain whale behavior and daily patterns in the ocean. Linguists could study the way sounds are formed and repeated like words in a language. Roboticists could design machines to dive deep and gather recordings. Computer scientists could handle the huge amount of information collected from the sea. When these skills came together, the group became much stronger than any single researcher on their own. A key member of the team was Shane Giroux.
The world's oceans and its ecosystems are under increasing pressure from climate change. Canadian Shane Gross is motivated by telling stories about both the positive and negative human impacts on precious bodies of water.
He had spent over 10 years following sperm whales around the island of Dominica. His long experience gave the project a direct link to living whale groups. He understood their habits and the best ways to record their calls in the wild. His knowledge in the field provided the foundation for the rest of the team to build on. The greatest change came with the use of natural language processing. This part of artificial intelligence makes it possible for machines to study human speech, and now it could be applied to whale sounds. By the year 2019, technology finally reached the level needed to match the dream. The team was ready to begin decoding whale voices in a serious way. Dominica is a small island in the Caribbean that became the main home for Project SETI. The island has a volcanic shape with steep coasts that sink quickly into very deep waters. This special geography makes it one of the easiest places in the world to find sperm whales close to land. Researchers can study them without traveling far into the open ocean, which makes long-term work much more practical. The whales near Dominica also form a steady population. The same families return every year, and many groups stay in the same waters for generations. This allowed the team to follow the same whales again and again. Over time, they could learn their family ties, their habits, and their ways of living together. Building a picture of whale culture became possible in a way few other locations could offer. In the year 2020, the project gained new strength. The TED Audacious project provided $33 million in funding, giving the team the chance to turn bold plans into action. Their vision was to create an underwater recording studio that covered an area 20 kilometers by 20 kilometers. With this system of listening devices, scientists could record whale sounds in real time and capture the flow of communication inside an entire whale community. With the perfect team and location in place, scientists were ready to build something that had never existed before, technology that could finally crack the whale code. Revolutionary technology. Arsenal. Project SETI has created one of the most advanced collections of technology ever used in marine research, giving scientists the chance to study whales in ways that were impossible before. The foundation of this system is a wide network of hydrophones, which are underwater microphones arranged in a grid pattern. These devices listen around the clock, recording whale sounds 24 hours a day. By placing the hydrophones in a precise layout, the system can also locate the exact position of a whale each time it makes a call.
You used to have to be underwater to hear whale songs, which researchers once believed were for mating. Hydrophones are bringing the symphony of sounds to the surface to a new audience.
This makes it possible to link specific sounds to specific animals and to watch how pods interact in real time across the ocean. The next breakthrough tool is a robotic fleet. These are autonomous drones that travel quietly through the water, gathering data without disturbing the whales. They are paired with suction cup tags that attach gently to the whales and later release on their own. The tags are completely non-invasive, yet they gather a wide range of information. They record audio, body movements, and even heart rate. They also provide details about social behavior, such as when whales swim close together or move apart, offering insight into their relationships. The final piece of this technology arsenal is the massive scale of data collection. Project SETI aims to gather millions and eventually billions of whale vocalizations. This will form the largest sound library of whale communication ever created. Such an enormous data set is vital for training artificial intelligence, which requires countless examples to detect hidden patterns. With this resource, scientists are beginning to unlock the complex structure of whale language and move closer to true interspecies communication. All this amazing tech was impressive, But it was useless without the one thing that would change everything: artificial intelligence that could think like a whale. The AI breakthrough. Collecting whale calls was only the beginning. The real challenge was turning endless streams of clicks into something that looked like language. To do this, scientists used powerful data processing tools. The first step was making spectrograms, which transform sound into visual patterns that can be studied in detail. From there, the team focused on identifying codas, the special click sequences whales use to communicate. With millions of examples gathered, deep learning and neural networks became the heart of the analysis. These systems are designed to spot patterns at massive scale, far beyond human ability. The results changed everything. The team discovered that sperm whales use a kind of phonetic alphabet built through rhythm, tempo, and small changes known as ornamentations. These subtle differences gave the same bass clicks many shades of meaning. Researchers also found signs of a complex vocabulary, where combining different codas created new meanings, much like words forming sentences. Even more surprising, they began to see hints of syntax. This suggested that whales arrange sounds using rules, building communication with a structure similar to human language. What once seemed like random noise turned into an organized system. With the help of artificial intelligence, the hidden patterns of whale calls started to reveal themselves as the early outlines of a true language. As the research moved forward, one idea became clear. Whale calls were far more than survival signals. They were not only about hunting, danger, or navigation. Many vocalizations took place in calm settings, showing that whales used sound to build and maintain social bonds. The conversations reflected relationships within families and pods. Subtle changes in rhythm formed what scientists call a rubato system, where fine variations in timing and tempo shape the meaning of each call. This level of detail suggested a rich world of personal and emotional expression. The findings also revealed strong cultural elements. Different families of sperm whales developed their own dialects, with slight changes in rhythm and ornamentation that set them apart. These variations acted like speech patterns in human communities. Young whales learned the calls of their family from older generations, showing clear cultural transmission. Over time, these traditions created identities that could be recognized within the larger population. Whale communication began to appear not as a simple tool, but as a mirror of culture. The sounds carried markers of belonging, history, and social life. By uncovering this complexity, scientists gained a glimpse into the whale worldview, where communication was tied deeply to family, culture, and identity. Discovering that whales had their own language was mind-blowing, but what scientists found hidden in those conversations was even more shocking. The goal of two-way communication. For many years, Project CETI focused on listening. Scientists spent countless hours recording and analyzing whale sounds.
Project SETI has turned to the Caribbean and the island of Dominica to record as many clicks as they can, transforming the stretch of ocean into an elaborate underwater soundstage.
Building the foundation for understanding their complex communication. The next step was far more ambitious, moving toward talking with whales in a way that could be meaningful to them. The team envisioned a real-time communication system, almost like an underwater chatbot, capable of exchanging messages using whale language. Instead of teaching whales human words or forcing them to imitate us, the goal was to speak in the rhythms, clicks, and codas that whales naturally use. The project began with small and simple goals. Researchers focused on basic interactions such as greetings, responses, and simple exchanges. This careful approach allowed scientists to experiment with communication without overwhelming the whales or introducing unnatural behaviors. The team could observe how whales reacted, learning from their responses while refining the system to respect their social patterns. Introducing such advanced technology raised serious ethical questions. Was it right to interfere with whale societies in this way? Could attempts at conversation disrupt family groups or harm social bonds? The team agreed that respect must guide every decision. Communication would only happen on the whales' terms, honoring their natural rhythms and cultural traditions. In the year 2023, a historic milestone was reached. Scientists successfully achieved an intentional interaction with a sperm whale. A specific coda was played through the system, and the whale responded with the same pattern. This marked the first direct exchange between humans and whales using their own language. It proved that the tools worked and showed that meaningful dialogue between species had moved from dream to reality. Having their first real chat with a whale was incredible, but it was just the beginning of something that could change the world forever. Broader implications for science and humanity. The success of Project CETI has the power to reshape science and human understanding. For marine biology, it marks a revolution. Instead of only observing whales from the outside, scientists can begin to understand how they think and live together as communities. This adds new depth to the study of animal cognition by showing levels of complexity that were never expected. The ability to communicate directly also creates a stronger sense of empathy, which could transform conservation and inspire greater protection for whales worldwide. The project also connects back to ideas from SETI. The same tools used to decode whale sounds could help prepare for contact with other forms of intelligence beyond Earth. Artificial intelligence that can find structure in whale clicks may one day recognize signals from deep space. In this way, the ocean becomes a practice ground for the cosmos, showing that communication across very different minds might be possible. The ethical impact is equally important. If whales prove to have language, culture, and identity, then the idea of whale personhood gains strength. This recognition supports conservation with a deeper moral weight. Protecting oceans becomes not only about ecosystems but also about preserving vast communication networks that belong to another intelligent species. The journey of Project CETI is only beginning. The team plans to continue expanding its research, building larger and more advanced systems to study whales in even greater detail. The current hydrophone networks and robotic tools have already transformed what is possible. Yet new designs promise to capture clearer signals, follow whales over longer periods, and analyze communication with more accuracy. Another important step will be the creation of more sophisticated communication protocols. The early success of simple greetings has shown that two-way interaction is possible. The next stage involves building structured exchanges that could cover emotions, social signals, or shared experiences. These protocols must remain gentle and respectful, allowing whales to guide the pace of interaction. The project may also grow beyond sperm whales. The same methods could be applied to other marine species, such as humpback whales, dolphins, or even smaller animals with complex sound systems. Each species studied in this way could add new insights into the diversity of intelligence in the ocean. Finally, Project CETI aims to connect its research to global conservation. By linking language discovery with protection of habitats, scientists hope to build stronger arguments for safeguarding marine life. Communication can deepen empathy, and empathy can drive meaningful change for the future of the oceans. The ocean is speaking, and now we are closer than ever to truly understanding it. Project CETI is opening doors to a new world of intelligence and connection. If this story inspired you, make sure to like, share, and subscribe.